Hi, and welcome to the RoboHub podcast. In today's episode, we will learn about a snake-like robot used to navigate and work in challenging environments. Our interviewer, Kate, spoke to Matt Bilsky, founder and CEO of Flex Solutions and inventor of the FlexBot. This is a small, customizable and affordable snake-like robot that is used to maneuver and perform tasks in hard-to-reach places such as above ceilings and within walls. Matt talks us through his academic and entrepreneurial journey, as well as the key features of his product, like its special joints and its imaging and mapping tools. He also discusses plans for the future of his company, as well as the challenges of understanding the product market and of creating an affordable, mass-producible robot.
Hello, welcome to RoboHub. Please introduce yourself to our audience.
Hi, I'm Matt Bilsky, founder and CEO of Flex Solutions.
Great to have you, Matt. Can we get started by telling our listeners what led you to find your company, Flex Solutions?
Sure. The story starts about 8 years ago. I was superintendent of properties, head of maintenance for one of the off-campus landlords. I'm here in Bethlehem, Pennsylvania. And I started with them when I was an undergrad in college, and they were buying old houses, like 100-year-old homes here, the old Bethlehem steel homes. They would buy them, we would renovate them, and then turn them into college student housing. And it was a great summer job. And without fail, I grew them from about 8 or 9 houses up to 35. And every time we do a renovation, we'd finish, and they would say, "Hey, we forgot to run cable television to this bedroom. Do you mind?" It's like, well, I get paid by the hour, but it sucks to do old work electric. So I had this idea, after I graduated undergrad, went into grad school, and was thinking about, what do I want to do a PhD in? What problem am I really interested in? And I'm like, wait, what if I invented a robot that you could put in through an outlet-sized hole, drive through the wall, have it drill through every stud and joist, pop out the end and pull your wires without a mess? And I haven't been a contractor for a while, and talking to my other friends on the job site, it was, a real problem that needed solving. And that technology ultimately became the FlexBot, where we distilled it down into mass deployable, affordable snake-like robots for, solving real-world problems with them in inspection, maintenance, repair. But it has been a very interesting journey going from, pure academic and then flipping my mind into entrepreneurial mindset and really, here's a problem we're going to solve, and working towards, what's the minimum viable technology that we can actually go to market with.
Cool, very interesting. It's cool that your personal experience motivated to your company. So I guess before we dive into the details of the robot, I'm kind of curious about, you mentioned that you have a personal academic journey as well. Can you elaborate on that?
Yeah, for sure. I am a, let's call it accidental academic. I was not a all-star student in high school, not because of aptitude, but because of desire. I was an all-star slacker. You contrast that with my sister, who's like the AP scholar, national merit, who just, school was for her. For me, I was always tinkering and building stuff and fixing computers for people. And also, higher ed and all, just originally, when I'm in high school, I'm like, I'm fixing computers. I'm making good money. What do I need to go to college for? And, hesitantly after a year off and all, ended up going to school. And towards the end of my undergrad, where, again, let's just say I definitely got a couple C's on my transcript in life. But I pulled it out because somebody discovered me, and this guy's like, you know what you do? You're a mechatronics person. I'm like, what's that? He's like, well, you build stuff, you wire stuff, and you program stuff. That's mechatronics. Like, there's a whole field of study about what you do. And it was like, okay. He's like, you should go get an electrical engineering minor, and you should do all of this. And so I kind of turned my academic career around because I understood what I was doing in college. Right? I had a purpose. And then he's like, well, do you want to come to grad school and, build more stuff and do cool things? And, long story short, the funding with him didn't work out, but started a conventional PhD program, doing research for a professor. Didn't love what I was working on, and had this idea that, well, they asked me to start helping to teach the freshman programming class. and that was paying my tuition and stipend. And so I had this notion that, wait, if I'm getting full tuition, full stipend from teaching, then my research is volunteer for all intents and purposes. So why am I volunteering to work on somebody else's project instead of working on my project? And that was this notion that I call an entrepreneurial minded dissertation, where I realized, okay, if I TA my way through grad school, then I can work on a project of my own choosing. And I found my soon-to-be PhD advisor, John Oakes, who is the head of technical entrepreneurship at Lehigh. And I approached him saying, well, can I start a company and fund it through, writing economic development grants, things like that, and TA my way through and call that a PhD program? He said, okay. And that was really what turned my academic career around, because I've always been entrepreneurial. I've always been a square peg in the world's round hole. So having to fit into the normal system didn't work well. Now that at the same time, I have a real mechanical engineering PhD. I had to take all the core classes. I had to do the general exam. I have a committee. So I had to satisfy all the full requirements of a mechanical engineering PhD. But when it comes to the project, well, the project was inventing the FlexBot. And because of the way I structured the PhD program, my advice for most people in life is read the directions. I read the rules on Lehigh's technology transfer site, and they made it very clear. If you're paid to teach, not to research, which when you're TAing, you are, and if you pay for the research, not the government, then you own your patents. And so that's how Flex Solutions came to be, of into this robot and developed it all while I was doing my doctoral work, got to file the patents and take the patents with me. And those became the core IP that the company's built around.
Wow, fascinating. It's very interesting to hear that you had an entrepreneurial mind student experience, and that kind of led the motivation for your company or as well. So just
Yeah.
to clarify, the timeline of your experience as a contractor and idea for FlexBot, is it around the same time as your experience as a student?
Yeah. So, let's put it this way. There's a story that I've told a couple of times of me being a little kid, 4 years old in a hardware store with my mom, and my mom's holding my 1-year-old sister, and I'm having a temper tantrum over an extension cord. I was always that kid. My grandfather was a carpenter, contractor. My mom grew up on a chicken farm, and I'm him. Just I can do math and he couldn't. That's the difference. So I've always been that person. And so, through high school, handyman, doing all sorts of things like that. So I rewired my parents' house and all that stuff. So I've always had that. But what I started to gain in, once I understood what mechatronics was really and started, focusing in on that, I started to gain the skill set to create what I always envisioned in my mind, make it a reality. There's a pet project I did. I have a YouTube channel, Matt Bilsky on YouTube. And when I was, 4 or 5, maybe 10, I had this idea for an automatic kite string reeler inner, right? So you don't have to go like this for hours. And when I was a little kid, I got the story's so old that I went to Radio Shack to buy the motor, right? So I went to Radio Shack to buy a little motor and have a little string, and it barely worked. And then a couple of years ago, I took a week and built it for real. And it's a full functioning product. And, people email me every once in a while, can I buy one? And it's like, well, I'd love to, but that's a whole side story. But I guess it's that notion of I always saw it in my head, but I couldn't make it a reality. And that's what I'd say my education for somebody like me, and what I think sets me apart from some of my maker peers, is I've taken all the core classes in mechanical engineering. I've taken PhD math, complex number theory, fluid dynamics and advanced dynamics. So I have a fundamental vocabulary and, the core ability to read and pick up on these things. And then I can teach myself a lot of this stuff. So I guess, in terms of the timeline of the FlexBot, as we digress, I always thought about something like that. So to think that I wasn't thinking about it, even when I was a kid rewiring, but then, I was paying my summers in grad school because I only had 9 months of support from TAing, still working for the landlords, doing all that repair. And so I had just turned down a full funded PhD with a, traditional faculty program where, here's 5 years of funding if you do exactly what we say for the next 5 years. And I just turned that down to go work as a contractor for the summer and figure it out. While I was trying to create this entrepreneurial minded dissertation. So during that time, I'm working 40 plus hours a week, running wires through houses and thinking about what I'm going to do with my dissertation and what company I'm going to found. And that's kind of where the FlexBot came out of. And it just so happens that my advisor, John Oakes, when he was in college and grad school, he was an IBEW, which is the International Brotherhood of Electrical Workers, the electricians union. He was a union electrician up in Newark, New Jersey when he was in school. So he instantly got the value of a robot that helps electricians and works with this. So it all kind of came together. It's one of those many stories that you hear of right place, right time, but it took a while to be able to make that a reality, right? I had to piece a lot of things together to end up being at the right place at the right time.
I see. Yeah, fascinating. One thing that really jumped out at me is you mentioned making things a reality really takes time, even though ideas or personal experiences always led you to that direction. Yeah, that's very interesting, and I love to dive deeper into that concept of what it takes to really translate to a product. But before that, let's give our listeners some context of the exact robot you're working with. So, can you tell us the specifics of the FlexBot?
Sure. So what we have here is a mock-up, or as I like to call it, the FlexBot action figure, because we have our posable parts. But the FlexBot is a snake-like robot, 1 inch in diameter, made up of these rigid links. And every link is identical. And what's at the core of it is our patented ability to both rotate around this joint, we can rotate here, but we can also make the links longer. So we have this ability to extend, rotate, and brace. And so what I invented as part of my doctoral work is this first true cylindrical joint. And that allows us to form like an S shape and brace ourselves against the walls of a cavity. So we're able to kind of get into places, and every one of these links has a camera. And we can take all those video feeds and stitch them together into immersive imaging, AR, VR. I'm going to lower the camera here. Stitch it together into immersive imaging, AR, VR, all of that sort of stuff. And all of this is available at a price point that makes it plausible to mass deploy these into every work truck. We've heard a lot from stakeholders in the construction, utility industry that all these workers have these tight places where they can't easily get to do what they need to do. And they're still getting it done, but they're contorting themselves, they're getting hurt, they're putting themselves in harm's way. So the notion is initially equipping them with a FlexBot, albeit handheld, or on the end of a pole or something like this that they can actually extend it. And this can actually go into that tight space. And once you're there, all the cameras are great for imaging, but we can put different end effectors on, like a spray nozzle for foam insulation, or a gripper to grab something you dropped, or a specialty camera, all sorts of things like that. And so initially we're looking handheld, but then ultimately that notion of put it in through an outlet-sized hole, put it in through the end of a pipe, and let it climb itself in all 3 dimensions.
Cool. Wow. Thanks for showing us the prototype It's very cool. So I think there's a few points that jumped out at me. So how did you understand that the need for a true cylindrical joint was one of the key aspects for the success of this product? Did you go through many iterations, or did you really tie into comparisons with what was out there as tools to help these contractors at the time?
That's a great question. I think I had the advantage of my mentorship in grad school was actually in entrepreneurship education, not in robotics. So, and let's be more specific, right? For the audience out there, I think many of you are aware, but I at least define robotics as the path planning, the CV, the more software oriented, the mathematics, the stuff that is not me. And I'm a mechatronics person, so how we build it, how we wire it. So, I didn't have mentorship, honestly, on either end. But as just a mechanically minded person, I saw what other snakes were out there, and none of them seemed to do it. And I guess I had this idea of what would I do if I was inside the wall? how would I climb it? And if you think about it, imagine you're in your chimney in your house, right? And you wanted to climb. Well, you would put your back against the one side, you put your hands like this, and you would inchworm your way up, right? It's how you do it in rock climbing, that whole notion. And so I had this vision in my mind of a robot that makes that shape and braces itself. Same thing I would do, right? How do I drill as a human on the top of a ladder? Well, I set my ladder up, I brace myself, and then I drill. So we need some sort of robot that can brace itself to drill. Otherwise, you need this super, hefty thing that's not going to fit through a 1-inch hole. And then in terms of the true cylindrical joint, I guess it took a while of, I had this idea. I had honed in really early on this notion of cutting cylinders at oblique angles, which actually dates back to the grandfather of Snake-like Robot, Shigeru Hiroshi, who I guess it was late 70s, published like the first paper on snake-like robotics. And he was proposing oblique cylinders. Now, he didn't figure out all the stuff I figured out for how to make it. And honestly, I don't think he had, the small brushless motors and circuitry that we have today. So again, right place, right time. We're at the technological stage where I can actually make it happen. Which frankly, when I first started this, some of the stuff that we're using wasn't quite ready for prime time. But just like the early internet companies, right? They started writing their code just until, domains became available and they were there at the right place, right time. So I guess it just kind of was an evolution, just trying everything. I've had the fortune of basically exploring every type of actuator that existed and figuring out, okay, we need a way to extend with force. And once you kind of detail your, we talk about, I'll talk about this a lot in product development. You need to have your needs and your metrics. Okay, this is what it needs to do. Here's how we quantify, does it do it? And here's the target specs that we have to hit. So I did a study in drill dynamometry. I built a machine that measured the forces and torques to drill. Well, I'm bootstrapping this thing. I couldn't afford an $80,000 drill dynamometer. So I went to Harbor Freight and bought a $70 drill press and built an automated, I called it Frank, short for Frankenstein's monster. It was this wooden behemoth that would, drill down through things and measure the forces and torques. And actually that was one of the best projects I ever did because it gave me a lot of practical experience and controls. And so much of the work I did to build that dynamometer is actually used in the real robot, even though it's this giant thing. And just kind of learning about what it had to do, learning about every type of technology out there, and can they do it? And then something that was really important to me as the entrepreneur, and my dissertation is Entrepreneurially Minded Design and Development. That's the title of a novel snake-like robot. But price had to be the third dimension on that graph, because you see this a lot in academic research. We got $5 million from the NSF to do blank. So they take their Amex card and have carte blanche to just buy whatever the heck they want to do it. Which, if you have the money and that's the game, great. But if you need to spend $1 million to make your prototype work, because the technology you use, right? Whenever I find a tech, I email the company, what will it cost if I buy 1,000 of these? Some technologies, the price dropped by 1,000. Others, it dropped by $10 if you bought one versus 1,000, which meant that technology was not scalable. So even if it would have worked or made my life easier, it was not the answer to the problem. And when you think about what the actual problem was, it needs to be affordable enough to actually go to market. And I guess kind of taking all that together, working through, living, eating, breathing, sleeping this for, years, it was pretty, I'd say probably within the first couple of years, I came up with that, actually how to do it. I'd say within the first few months, I came up with this notion of rotation and extension, but then how to actually create it and how to create the mechanism took about another year to sketch it out. And what's really cool here is, looking back to our first patent drawings, or here I'm on research notebook number 28. When I go back to research notebooks number, 1, 2, 3, many of the things that are in the final FlexBot work, but were originally sketched in those first notebooks. And that all kind of dates back to that notion of like the kite string reel or inner, where once I see it in my head, it's going to work because I figured out exactly what it's going to do. But then you have to go back and fill in the details on explicitly how we're going to do each of those steps.
Wow, thank you. Very, very detailed answer. And I think it kind of links back to the question that sometimes the biggest problem, just asking ourselves, what is the right question to ask? And I really like how you phrase that. You would envision, what would you do if you were a snake or snake-like robot within the walls? And yeah, and this also ties into your theme of a lot of experimental work that led to your continuous learning, and as well as your entrepreneurial-minded kind of design dissertation. I guess now let's get into the other aspect of the robot in terms of the software, the sensing and controls. I know that it's not your primary focus, but could you tell us a little bit what it's capable of in terms of imaging or autonomy?
For sure. I could say it's not my area of expertise, but I very much have to focus on it because as CEO, the buck stops here. So building a team around that. Initially we have, like I said, a camera in every link. And we also have very high precision encoders on the outputs of all of our joints. So you either use expensive motors that don't have backlash, or you figure out how to, sense what's going on well enough to account for it. So we have the encoders, we have the cameras, and then we also have 2 IMUs in every link, one in this half and one in this half. And we can fuse all of that data together to get towards, the golden V-slam. That's what everybody's chasing down, this visual simultaneous localization and mapping. So can we use the camera data plus the IMU data plus the encoders and stitch all that together to figure out where in space is this stick as I'm waving it around, but also mapping the world around us, right? So the first thing is, getting the image. Then the next question is, once we have all that imagery, can we figure out depth data from the cameras? And we're starting to see that, photogrammetry more and more, that even your cell phone can do it. And then once we have all of that, then comes in the robotics path planning of how do we not hit anything? And so we have a few different teams that are working on it. Through the Pennsylvania Infrastructure Technology Alliance, or PITA, we've received a couple of grants to work with some of my former colleagues at Lehigh University, who are path planning experts. So they've been working, and actually they just had a paper accepted, which is really exciting, on their work in how do you solve the path plan to account for the fact that you need to brace to drill. Most of robotics is how do we avoid hitting things? Whereas in our world, how do we use the things that are there to our advantage, right? You're not going to pretend that the wall isn't in front of you when you're on the top of a ladder. No, you're going to put your hand on the wall. And that's the same thing that we're looking at with the FlexBot. And so they managed to start actually writing those algorithms to do it because, again, people haven't really considered this. And then we also have a team, how we got connected, who are computer vision experts who are working on this problem of stitching all the video together. And there's different stages of it, right? So first you track with an external tracking system while you have all your sensors and cameras. And then you use the ground truth from your real system and you collect enough data. And then you can start training models and actually getting towards that automatic. And that's why we're really focused on cobotics initially. You asked about my thoughts on robotics. I like to think realistic view about where we are today with autonomy. And the reality is, even when put on the stand, Tesla acknowledged that their self-driving car does not self-drive, right? And that's probably the autonomy field to which we're collecting the most data right now, right? Every car is essentially a data collection system, just as the FlexBot is. You just have more cars out there. And so they're using all that data to train self-driving. Well, initially, when you have a user manually shoving this into the place where they need to work and interacting with that environment, and we collect all that data, well, we're collecting it in places that people haven't collected before, inside of walls, I don't know if there's an entire YouTube channel of inside of walls, right? We need those, petabytes of sensor data to then train and create autonomy. And that's when this notion of the snake expanding and going through the walls and doing all that on its own becomes a reality. But what we as a company have realized is we don't need to be autonomous to generate value for our stakeholders. Even this semi-automatic, cobotic is something that people are really excited about. And so we can use that today on our way to, the autonomous future of tomorrow.
Cool. Can you define exactly what you mean by cobotics?
Okay, so I guess my definition is cobots are robots that work alongside humans, and I like to put the asterisks on it and like improve the human experience and human capabilities, right? So we're not talking about replacing jobs. We're talking, at least I'm not. I'm talking about amplifying your skill set. So you have a worker who knows exactly what they're trying to do, but they can't quite get there. So they bend a coat hanger, they shove a stick in there, or they use a FlexBot. This is then a cobot, right? So that human is still here doing what they're trying to do. And so that's, I think, for the time being, the next few years, there are industries in where, look at automotive, right? Where you just have the transfer presses and the robot just moves it between the big strikey thing. And then you have automatic packaging or warehousing, things like that are super controlled. And, the expression of you could do it in your sleep, that's the sort of thing that those robots are great at. But when we get into these highly dexterous tasks, our posable thumbs and our jazz hand, right? We can do things that nobody else can do. And a robot only dreams of being able to do right now. And while, yes, a robot could do it, the economics of it just doesn't make sense. And then there is an aspect to cobotics of safety, right? You'll see the big industrial robots, they're behind fences. It's like why there's a cage, and when somebody's swinging a baseball bat, you stand behind it. Because if you stand too close, you're going to get hit with the bat because your buddy's not looking out for you behind them. And that's the same thing with most industrial robotics. They're in their cage because they're not perceiving people, right? They're not taking everything in. And whereas cobotics, you have robotic arms that are compliant. So if they hit you, they don't hurt you. I mean, the reality is this thing is strong for what it is, but it's not going to kill you, right? It's not going to be able to whack you in the head hard enough to hurt. And so that's where, cobotics and safety are another thing of making sure that the robotic system is safe enough to be handled by a human and work alongside a human.
I see. So it sounds like your company is driving towards the cobotics, something that produces value and helps the tool is intended for, at the same time kind of driving towards building that data set to train for autonomy.
Exactly. So, I mean, we think that data really is, it's the fuel of our future. So we have, the three aspects of data. You have data to improve our capabilities, but also data can offer insights to customers. Where if you're a building management company and you have, we've been talking to some of the largest building management companies in the country. And so they have thousands of properties. Every one of those has a FlexBot, and every FlexBot's out there all day doing stuff. Well, you have enough data to start to predictive model. It's like those elevator commercials with Watson, where it's like the elevator called the service tech, and the guy at the front desk is like, "Why are you here?" The elevator called me, right? It's like, oh, we've seen enough things to predict that when it looks like that, next week we're going to be back to fix it. So maybe we could just do something about it today. So then you can also get company level. And then one step beyond all of that is macro data insights, where, if you have enough sensors out there in the world sensing particular things, you can start to glean insights at a higher level about what's going on. Think about if you had environmental sensors all over, you could predict, right? That's how the weather forecasting works. They have a bunch of these over here, and they take the data, they fuse it together, and they come up with a prediction for what they think the weather is going to do. So a FlexBot is just a giant sensor platform. So if we're using it in certain applications that we're sensing, let's say, some sort of commodity, and we're starting to get trends in what's happening with those commodities across, can we then, predict pricing or availability or things like that? And I mean, frankly, you see it with the smartphone companies. They have 1 billion people with smartphones in their pocket, and we trade our privacy for affordability of services. And that's a whole thing that we don't need to go down. But fundamentally, to think that Apple and Google aren't figuring things out based on every sensor they have out in the world, right? Like, yeah, I think that they can figure what. I'm just talking off the cuff here. If I wanted to think of what the next up and coming band is going to be, right? I guess you could see who bought tickets, or you could, scrape all the small concerts and see how many of your users are there. And you can start to figure out trends based on how many people saw this band. Even if you didn't know about the tickets and you didn't know about anything else, you saw band names and cell phone locations, and you could track who was trending and who kept coming back. And is it one person, so it's niche, or did everybody who went to that concert went to the next one because it was so good? So just an anecdotal thought experiment there, but that's kind of the notion.
Yeah, I love all your examples, making it very relatable. But also, like, kind of tying back to the FlexBot, what does it look like from the customer's use case perspective? You mentioned it will be important to give insights to the customers. Do the customers, you mentioned one use case of drilling. In terms of the end effectors, do they purchase your robot with custom end effectors, or do they really also create their own use cases?
Oh, that's a great question. So we're an early stage robotics company. We're going into pilots this summer with the technology with some strategic partners that we're really excited about. And there's a couple of avenues. I think right now our if I had to say statistically most likely, we're thinking about an open standard, let's say, for the end effectors, with the notion that other people can create their own end effectors and put it on. Like we have a Gazebo, which is a robotic simulation system, digital twin of the bot, that right now the plan is to share with the world so that everybody can start developing their own applications on the FlexBot. And, we think this is a great research tool. Why? Because we're looking at a couple $1,000s, not tens of thousands of dollars. So even, makes it affordable to have a few in your lab and then hire grad students to play with them as opposed to buy a robot and be stuck with no grad students. So making that open, we think that people can develop their own end effectors. And we've kind of heard this from partners too, where they want the Android phone and they're going to write their own app for it. And so that's one notion, but there's the caveat of, as a business, maybe some major power tool company wants to buy us. And what do power tool companies love to do? Invent their own battery standard that only works with their tools. So you have the FlexBot and it's got your tool company name here, and they can release a whole line of end effectors. But that's the moonshot. Reality right now, we're looking at letting people develop their own end effectors for it. And that's because if you even look at regular robots right now, you have the arm companies and you have the end effector companies, because the end effector is a robot in and of itself that's got its own nuances and complexities. So we think that, there's a place for both.
I see. Yeah, thanks for elaborating on those notions. So now I'm really curious to hear about the business side of Flex Solutions. So you mentioned you are the CEO with lots of responsibilities overseeing all the focuses of the company. What would you say are the biggest challenges when just starting out the company?
Yeah. What's the biggest challenges? I think the biggest thing, and anybody who listens to Steve Blank Startup, I used to teach when I was a faculty member, the integrated product development, so product development capstone, is finding product market fit, or figuring out who your customer is and what are the pains and gains. How are we going to help this customer? Because without a customer, you're just working on a hobby. You're working on a fun thing. Or you're working on deep research that will benefit us in the future, but that's not starting a business. That's doing research, and it's a different business in and of itself. So figuring out who your customer is and what their needs are, customer needs, their target specifications, and then figuring out how you're going to address them. I think that's the forward way to do it. But it's really easy to get caught in the I know everything and this is the world's greatest idea. You ask your buddies over a couple of beers and they say, of course it's a great idea. But like, you brought home a macaroni painting from kindergarten and your mom said that looks great. No, it didn't. But they said what they wanted to hear, right? And so that's really getting out and talking to customers is the hardest thing to do. It's also the most important thing to do. And that's, I know in robotics, one of the toughest things is finding that product market fit. And for us, we ended up with the bell curve where initially electricians driving through walls, drilling holes through studs to pull wires. Okay, this is going to cost $15,000. It's going to be this big metal thing. And then had this notion of, wait, what if we lowered the capabilities a little and lowered the price to make it affordable and mass deployable? Okay, who needs $1,000 steerable endoscope, right? And even, people who are excited about the tech in general. Oh, that's a really cool movement. Will you write me a check? Well, I don't know what we do with it, so I'm not going to write you the check. And we spent a while as a company, a couple of hard years, talking to hundreds and hundreds and hundreds of people all across many different industries: construction, utility, mining, aviation, naval, and coming up with the use cases. And even once we got the use cases, we then had to backfeed them into what's the first thing we're going to do? Who's the first person to write us a check? And what can we do to build value? What can we do to build value for them? And when we honed in on this construction space, but this notion of you just bought a building from somebody else, it's an older building. What does it look like? You don't have a digital twin of it. You need to do some renovations, but you have no idea where everything is. So right now you have to pop up every ceiling tile and stand and scan and do all this stuff. And it's invasive. It makes people stop working. It makes a mess. What if you could just stick a FlexBot up there and have it map and inspect and actually do all that without the damage, without the hassle, and frankly, without having to get on a ladder? Because I was watching a video last night about wind turbine maintenance. Tom Scott, he's a big YouTuber, and they let him take the emergency rappel off of a wind turbine. And they were just saying about all of these issues. And basically, the one guy who worked there said, I mean, this was in his opinion, but I think it's an interesting anecdote. It's safer to be a wind turbine technician than to work on the top of a 6-foot ladder, because that wind turbine technician is clipped in at all times. Falls are the leading cause of death on construction sites. 1 in 5 workplace injuries happens at heights, right? Think about even a step stool where you're not paying attention. You're in a library filing books and you fall up. That's a workplace injury, right? So this notion of don't get on a ladder, don't get on scaffolding, right? Or minimize the amount of time you're there. Just pick the one ceiling tile off, go back down and do what you got to do from the ground so you're not leaning off that ladder. So we've really kind of honed in on this is something that technologically we can do that generates value. We've heard it from some of the largest players in the construction industry, but it's taken a long time and lots of just emails sent into the black void of trying to find that product market fit. And I guess the tenacity I've developed over the years from a number of different things that I've been through in life, allows me to keep fighting through. And that's what you got to do if you're going to make it. That's for sure.
Cool. Yeah, it sounds like lots of conversations to define the product market fit and the use cases. And that also kind of led you to some of your biggest assets of focus on affordability and mass producibility.
Exactly.
Cool. And I imagine on the other side, you must have had a lot of conversations, in addition to the conversations you had with end users, to people with similar mindsets, your collaborators. Or so, how did you build your team?
Yeah, that's a great question. I was a lone wolf for a very long time in this project because I was developing the tech, and while I was a grad student and then a faculty member, I had a few, student interns, things like that, some capstone teams who would help me with, um, specific things. But I was bootstrapping. I, was on a grad student salary developing a product, so I had to scrape by and do a lot of the initial work by myself and get it to the point in which I can, show investors what was going on, and then started raising funds and brought on Jill, who kind of has been leading our operations, or takes my verbosity and can make it clean and lean and gives us a nice website and slide decks and really helps bundle things up and does a great job of keeping me out of trouble. And then went through Startup Accelerator and um, closed some more funding and brought on Jason, our head of strategy, Mark, our head of product. And in terms of development, it's been a process of use. We kind of leverage a lot of very good contractors who, I have a gentleman, Brent, who's unbelievable at Altium doing PCB design. So I'll be like, here's the circuit. As a mechanical engineer, I know it'll fit here. Figure out how to route this. And he'll say, and then he'll come back the next day with, I did it. And, and so that's how we managed to miniaturize our circuitry down to, fit inside the link there. And the same thing with robotics. I found some great roboticists who, we couldn't afford as, full timers, but they have some spare bandwidth and they're really passionate about, what we're doing. And they know, we're solving problems in robotics that people haven't dealt with, right? This problem of how you do path planning for a joint that extends or rotates in a single mechanism, that is not built into any motion planner that exists right now. So it's like, hey, who wants to be the one to implement that? And so we've been building out the team, and then as we're using somebody more and more, and frankly, we're going into our next raise this summer to really pay for go to market and to grow our internal team. That we're using 80 hours a month of roboticist time. Great, that's somebody who should be on the core team. And so we're able to be very lean, which I think as a hardware startup, especially where it's not as well understood, and we just have so many more costs, even pre-COVID, right? Like it's just we have to buy physical things. It's not like you could just click a button and AWS doubles how many servers you're running. So I think the lean aspect has really allowed our company to get quite far as a robotics company for a fraction of what our peers are doing. And that kind of fits all into this bootstrap affordability mindset and really taking this, if we're going to make it so that you can someday see this on the store shelves of Home Depot and Lowe's, we need to think that way about everything we do. And that's kind of from all aspects. That's how we've approached it.
Interesting. Yeah, thanks for sharing the key aspect of focusing on being lean. So I guess before we wrapped up, I really like to hear what is next for you, both in terms of for your company, Flex Solutions, or what are you looking forward to learn next personally? Because there's a theme of continuous learning throughout this conversation.
Yeah, sure. So for Flex, we're really looking forward to come May or June. So I guess later this month. It is May already. Hey, may the 4th be with you. Congratulations. It's Star Wars Day. So I think, end of this month into beginning of June, we're going to be doing some tests with the actual hardware, which is, it makes me giddy just to think about because it's been such a long road to getting it to be a thing. I think the best analogy is if you go watch Mark Roper's video. He's the YouTuber who was the ex-NASA engineer. He did a video about the Ingenuity landing and what it was like to work at JPL for 8 years on a rover and then see it land. Well, go watch that and you'll understand how I'm going to feel in June. And so I'm really excited for that. And like I said, we've finally gotten some really good traction, and I'm really excited to work with these partners and really demonstrate the value of the FlexBot as we go into our go-to-market fundraise and grow the company into a seed stage startup that's building value and going to market, which I'm really excited about. And then personally, um, I'm really looking forward to finishing the FlexBot so I could do a couple pet projects. What's cooking in the pipeline? I don't know Python, to be honest. I can reverse engineer it and I can modify people's code in it, but I haven't done a Python project really. So there's a couple projects I want to work on. I have all these air conditioners that are window ACs, and I want to take I do a lot with ESP32, and I want to make it so I can remote control the AC, but you have no idea what's on the screen. So I want to use the camera, beam the image up, and then read the control panel. And that way you can have a closed loop on what it's actually at 63 and then hit up. And so I think that'll be an interesting web project. And on the hardware side, I wear custom orthotics in my shoes and they're a few $100s. So I want to 3D print duplicates of them. And so I have, one of my older 3D printers. I originally tried using a bed probe to measure the height, but it didn't quite work because it's quite big. So I found this old laser distance sensor on eBay. So I'm going to mount that on and write a script to make it measures a few let's say 15 microns. And so we could actually do 3D contour scans of the orthotic on a $200 3D printer with a $150 laser sensor and then duplicate it. So even right off the bat, that one pair that I make will be the same price as if I bought everything. So those are a couple of projects that I have cooking, and all of those, along with the rest of my projects, I always put them on my YouTube channel, youtube.com/Matt Bilsky, or mattbilsky.com is my website with a lot of my personal projects. And then we have Flex Solutions, which is flexsolutions.com. And hey, we also have a YouTube channel. So if you want to see the FlexBot in action, look up Flex Solutions on YouTube and hit that subscribe. We're trying to grow our subscriber count, but that's how you'll see the first, real demos of the FlexBot. They're going to go to YouTube first. But yeah, you can find us on LinkedIn and all that as well.
Cool. Yeah, we'll for sure feature those links, and I'm sure it'll be very fascinating to follow up and check out. So one last question. So given your experience both as in the academic world as a student and as an educator, and your experience as an entrepreneur, what would be your top advice for graduate students or researchers who are interested in entrepreneur?
Yeah, that's a great question. I think it's important to understand what it means to be an entrepreneur and what it's going to take. And then also keep in mind that a tenured faculty member or tenure track fac is kind of an entrepreneur. They're creating a business around their brand of research, right? They have to go and bootstrap it with their startup funds and then fundraise. So you can be an intrapreneur. That's a phrase so you don't start the company, but you take that entrepreneurial mindset, that curiosity, that connections, that creating value, and you bring it to the organization you're at. So you can have an entrepreneurial mindset as a faculty member or as a grad student there. Or if you want to start a business, again, I think the quote unquote right way, right? There's always outliers to everything, right? But the most straightforward way is while you're in grad school, learning about problems and really getting that customer story nailed before you go into business. With a great customer story and your technical background, you'll be set. But it doesn't matter how good at building stuff you are. If nobody cares about what you're doing, it's not a business. So I think that's really important. And I think the other caveat, at least, or my advice for graduate students, is when I'm looking at hiring roboticists and all, I used to say this about undergrad, but it's honestly the same about grad. Every undergrad in the US who has an engineering degree, for the most part, went to an ABIT, which is the Accreditation Board accredited college, which means you took the same classes as everybody else. So telling me what classes you took is redundant because you told me you have a degree from an ABIT accredited school. So that doesn't tell me anything about who you are. Just told me you got a college degree. I want to know about the projects you've done, like in machine learning or in sensor fusion. Have you actually bought an accelerometer and waved it around and fused that data? Or did you do it on a class project? Because doing it on a class project doesn't mean you know how to do it. Because I bet you that your professor picked a data set for that project that was going to work, right? It doesn't have the real world issues in it. And as somebody who's trying to, at least as an early stage startup, we don't have the mentorship capabilities to have a senior developer who has a junior, who has an intern, and they have this mentorship pipeline. We just need people who have done it before. So really, pet projects. I talk about my YouTube channel. Well, really, those are almost business expenses because I'm learning how to do the things that I then do in the lab here. And what I think is really important for grad students, undergrads, is starting an online portfolio. Like I said, I have mattbilsky.com. I take everything, the school projects I've done, the courses I taught. I put up my course in mechatronics, my course in dynamics. They're up on my website for free. So anybody can see all the stuff I've done and learned. And I think for graduate students especially, and I think international students even more so, because it is so competitive for them with the visas and all of this, it's really important to stand out from your peers. And GPA isn't going to do that. And lineage isn't going to do that. At least for me, I want to know what you've done. And I think an online portfolio, and doesn't have, you'll see mine. I used to have Wikipedia. It's nothing, it's not going to win a design award, but it at least lets anybody who wants to know the stuff that I've done over the last 12 years or so, it's all there. And, a little bit about who I am and what I do. And I think that it when I see that for people, when they apply and I see some stuff there that I'm like, wow, that is what catches my eye, because I'm like, this person made a knitting robot while they're getting a PhD in, fluid dynamics. That shows that this person has the initiative to learn and they were curious about something, right? And sharing that with the world. And as one funny YouTuber, AVE, says, build cool stuff and put it on the internet. It's amazing what people click on, and you can learn a lot.
Cool. Thank you so much. Thank you for the insights and thank you for your time. So best of luck to all of your projects, and I look forward to hearing news both from Flex Solutions and your personal projects.
Really appreciate it. Thanks for all the great questions and the time.
And that is it for today. But please check out the links in the description for videos of the FlexBot, or visit our YouTube channel to watch the video version of this interview. And if you haven't heard enough about robots quite yet, simply go to robohub.org/podcast for loads more exciting episodes, as well as news and views about robotics. And if you have any questions or feedback for us here at the RoboHub podcast, we are always happy to hear from our listeners. So just email our podcast lead at abate.de.mey@robohub.org. We'll be back in 2 weeks' time. Until then, goodbye.